A Moxon Yagi is a highly effective, compact choice for LEO, that is low Earth orbit satellite operations, particularly for handheld use. By combining the wide beam width and excellent front to back ratio of a Moxon rectangle with the high gain of Yagi directors, you get an antenna that is easier to point at a moving satellite than a high gain narrow beam traditional Yagi. Most LEO satellite work happens on 2 meter VHF and 70 centimeter UHF bands. A traditional Yagi for 2 meter can be quite long and unwieldy for handheld operation. The Moxon Yagi solves several practical problems. The Moxon rectangle folds the elements, reducing the 2 meter wingspan by about 25 to 30% compared to a standard dipole or Yagi. It offers a very clean radiation pattern with a deep null behind the antenna, which helps eliminate local terrestrial interference during weak signal satellite passes. It has a wider sweet spot than multi-element Yagi, that is the bandwidth, making it much more forgiving if your tracking isn't 100% precise. A well-designed Moxon has a native impedance very close to 50 ohms, allowing for a direct coax feed without complex gamma matches or hairpin batches. A common configuration is to use a 2 meter Moxon as the driven element and mount several 70 cm Yagi elements on the same boom. Many builders use inductive coupling to avoid using a diplexer. In this setup, the coax is connected only to the 2 meter Moxon. A 70 cm slave driven element is placed very close to the 2 meter element. Through mutual induction, the 70 cm energy is transferred to the UHF portion of the antenna. For a 2 meter 145 MHz, 70 cm 435 MHz build, a typical design like the well-known M1 GEO looks like this. VHF section, a 2-element Moxon, 1 driven element, 1 reflector. UHF section, 3 to 5 Yagi elements, director and or reflector, optimized for 435 to 438 MHz. Boom, usually made from 20 mm or 25 mm PVC pipe or wooden dowel. Operating considerations. Polarization. Satellites tumble as they pass over. Since the Moxon Yagi is linearly polarized, you will need to rotate the antenna on its axis, wrist twist, during the pass to maintain the strongest signal as the satellite's orientation changes relative to you. Full duplex. If you plan to transmit and receive simultaneously, standard or linear transponder, then ensure your coax is high quality like RG58 or LMR240 to minimize loss on 70 cm where cable attenuation is much higher. I am using a short length of cable, that is just 10 meters, and mounted the Yagi on a vertical mast, which is rotated manually when needed during a satellite pass, as I do not have the option of going outside and operating from an open space due to local constraints. Still, I get to work about half of the pass where the signals are maximum, though I may not get lower elevation passes. Occasionally, I do get a DX at 5 degree elevation as well.